Let's see some examples on thermodynamics that used to come in exams. Here, students, you are seeing a PV diagram. So a cyclic process is given. 1 mole of an ideal monoatomic gas, right, is taken around the cyclic process ABCA. Work done by the gas we have to find. First point. Heat rejected by the gas in the path CA and heat absorbed by the gas in the path AB, right? And we have to also calculate the net heat absorbed by the gas in the path BC and maximum temperature attained by the gas during the cycle. Okay. So let's see one by one. Students, you know, work done means the area enclosed, right? First page is asked about work done, correct? And work done means how much? Area of closed curve, correct? Area of closed curve, correct? That is the area of closed curve. Getting, students? Next, that is area of triangle, no, students? Yes or no? This is the area of the triangle, correct? You have to find this area. That is dW is equal to area of closed curve, that is area of triangle ABC, correct? And that is dW is equal to how much? Half into, you know, base into height. See here. Student, what is the base? This is 2V naught, this is V naught. So 2V naught minus V naught is V naught, na? And what is the height? 3P naught minus P naught. 2P naught. Are you getting all? So that is half into V naught, base into height is 2P naught. So that is P naught, V naught. This is the work done, correct? Next, in point 2 is asking heat rejected by the gas in the path C. Student, see here. In path CA, C to A you see, pressure is remaining constant. So this is a isobaric process, right? And it's returning C to A, right? Anti-clockwise, sorry, clockwise, right? So this rejected means isobaric compression, that one, right? When heat is rejected. So number 2, path CA. In path CA, heat rejected. Heat rejected, right? That is isobaric compression. This is isobaric compression process, right? That is isobaric compression process. And so students, you know, QCA is equal to pressure is constant. So that is NCP delta T. Yes or no? This formula will put NCP delta T. Monoatom, 1 mole gas, 1. And we'll see molar specific heat for monoatomic gas. That we'll see in kinetic theory of gases 5 pi by 2. Into change in temperature is temperature at A minus temperature at C. Correct. So that is, we want to find TC. TC is equal to how much, students? 2 P naught V naught divided by 1 into R. Correct. PV is equal to nRT, na, students? You know. And temperature at A is how much? That is equal to temperature at A is equal to P naught V naught by 1 into R, monoatomic real gas constant NR. So by putting the values, you can find delta Q, change in heat from C to A, is 5 R by 2. That is TA is P naught V naught by R minus TC is 2 P naught V naught by R. Correct. And subtracting, students, will get minus 5 by 2 P naught V naught. Understood? Understood or not, students? C to A. And you see from A to, next he is asking from A to B. A to B is what process? Isochoric process, right, students? Then volume is constant, so we'll put NCV delta T. Yes or no? Are you listening all?
Yes, sir.
Then student, heat absorbed.
Yes.
Heat absorbed by the gas in the path AB. Heat absorbed by the gas in the path AB of isobaric process that is delta QAB is equal to N CV dt. That is equal to N molar specific at constant volume 3 by 2R, right? into tangent temperature Tv minus Ta. And from here also you can find Tv minus Ta. What is Pv is equal to nRT formula? That is 3R by 2, take outside. Tb is 3 P naught V naught by R, because 1 into R, 1 mole of gas, minus P naught V naught by 1 into R, right? Correct, students? Getting? So by solving, you can see this is 3 P naught V naught minus P naught V naught, 2 P naught V naught. So that will be 3 RR cancel, P naught V naught. Understood? What is the heat absorbed in the heat absorbed by the gas in the path of AB? AB is isobaric, right? Because pressure is. Understood, students, or not? Pressure is remaining constant here. A to BC. Pressure is changing. But oh yes, volume is constant, so that is not isobaric. This is isochoric process. Yes or no, students? So this is not isobaric. See here, number 3. NCP delta B. This is iso heat absorbed by the gas in the path of isochoric process. No, this is for fast line, okay? But here second bit, that is heat in the process A to B. This is not isobaric, student. This is isochoric because volume constant, right? Understood, na? NCP delta T. All got? Understood, student? Then number 3C. Yes,
Yes, sir.
net heat absorbed by the gas in the path BC. Number 3, third bit. The net heat absorbed by the gas in the path B to C, right? And student, for B to C, what we have to do? See here. We have to go for first law of thermodynamics, right? Student, D cyclic process, so change in internal energy is 0, right? Yes or no? In a cyclic process, the total change in internal energy is 0, right? So dq is equal to dw, and dq is equal to how much? dq A to B plus dq C to A plus change in heat B to C is equal to dw. Yes or no, students? And you know AB delta Q AB, how much you got? 3 P naught V naught, na, students? Delta Q
Yes,
CL,
sir.
how much you got? 5 by 2 P naught V naught, correct? Yes or no? Then delta Q BC is equal to change in work done dW, and total work done you got how much from the area? P naught V naught, right? So from here only you can find delta Q BC, that is equal to how much? By solving you will get P naught V naught by 2. Understood, student, how to find the heat from B to C? Net heat absorbed by the gas during the path BC. So temperature will reach maximum, student. Net heat is absorbed by the gas during which process? During BC process, right? So that is P naught V naught by 2. So as net heat is absorbed by the gas during path BC, temperature will reach maximum between B and C. So you can write here. It is asking now when temperature will be maximum, right? As net heat is absorbed by the gas during path BC, right? So temperature will reach maximum. So temperature is maximum between B and C. Then at last, student, see the important part. It is asking the maximum temperature attained by the gas. We have to find that temperature. So we have to go for the formula. So students, see equation for line BC, right? Line BC ka equation for line BC, that is equal to PV is equal to nRT, students, right? PV, so that is 2 P naught V naught, 2 by P naught V naught V plus 5 P naught. How did it come, students? Students, you know PV is equal to nRT and N is equal to 1. So P is equal to how much? RT by V, correct? Yes or no? And temperature, for maximum temperature, student, change in temperature dt by dV is equal to 0. Correct? And if I will solve this one, then I will get 2P naught by V naught into 2V plus 5P naught is equal to 0. So from there only you can get V is equal to 5 by 4 V naught, right? And you know, student, this is equation 1 we got, RT we got this much. RT is equal to how much we got? Because V is equal to RT, P is equal to RT by V. So from here only, students, you can find RT is equal to, right? RT is equal to how much? Minus 2 P naught by V naught V square plus 5 P naught V. The total equation, right? And this is one equation and this is one equation, student. Compare both the equations, you will get RT maximum is equal to minus 2 P naught by V naught into 5 V naught by 4 square plus 5 P naught into 5 V naught by 4. That is equal to minus 2 P naught V naught into 25 by 16